Okay, so we proved that Cauchy-Schwarz theorem and the inequality. All right, so again, very important. Then let's have a look at this theorem. So first part. So the norm function, it's the properties of the norm function. Okay, norm of x is equal to 0 means that x is actually equal to the 0. To the 0 of the space. Well, we already knew about this, okay? We already knew about that because that's just the definite positive property of the inner product. Next one, for all x that belongs to E, we have that. Sorry, for all x that belong to E, we have that the norm of lambda x is equal to absolute value of lambda times the norm of x. Oh, okay. So that's worth working on that. So we're working on the norm of lambda x, right? So because it's the kind of thing I don't want you to remember that we get the absolute value in the end. All right. So what does it mean? Yeah, let's take the square of that. So we're going to have, so why do I use the square? Because I don't want to write the square roots yet, right? So that's lambda x inner product with lambda x using the linearity in the first place, in the first input. That's going to be lambda x with lambda x. Using linearity in the second input, that's lambda square x with x. Okay, so that's lambda square norm square of x. All right, so now if I go to if I use the square root now, I use the square root everywhere. So square root that will be equal to, well, of course we've got x sorry, without the square norm of x because it's always positive, but here don't forget we have the absolute value of lambda. Square root of lambda square is absolute value of lambda. All right, that's something you have to remember. I didn't have to put that for the norm of x because obviously the norm of x is already positive. All right, so that's an important one. The triangular inequality. Well, it's a nice one and it's an application of Cauchy-Schwarz. So triangular inequality. Let's work on x plus y. All right. Let's work on the square of that. So that's x plus y, x plus y. Again, you can pause and try to see where you're going here, right? So that if, maybe pause and expand that inner product to see if you know how to apply all the properties of the inner product. Okay? So if you expand, you will get so x plus y plus y, x plus y, sorry, and then equals to so sorry about that, sometimes my computer does things I don't fully understand. Equals to let's put, so if I'm going on this expansion, so that's x plus xy plus y x plus y. Okay, and which gives us, so norm of x square plus 2xy. Well, we've already done that one. Plus norm of y square. Okay, and now I'm going to use Cauchy-Schwarz inequality to bound that above, right? That's going to be smaller or equal to 2 times norm of x, norm of y. That's the Cauchy-Schwarz inequality. So that's smaller or equal to x squared plus 2 norm of x norm of y plus norm of y squared. And you can see that this last expression is actually exactly norm of x plus norm of y squared. Okay, so we have what we were looking for. If I take the square root of all that, I'm going to get that norm of x plus y smaller or equal to norm smaller or equal to so we have that the norm of x plus y will be smaller or equal to the norm of x plus the norm of y. Okay, that's our triangular inequality. All right, and which tells you basically that well, if you remember the meaning of that in R2, for instance, in R2 it tells you that if you've got, let's say that you've got that point and that point, okay, you have two vectors in R2. Taking one plus the other gives you, so that's vector u, that's vector v, and the one in the middle is going to be vector u plus v. What does it tell you? It tells you that the norm of the vector u plus v is smaller than the norm of the vector u plus the norm of the vector v. In other words, that it tells you that the shortest path is the straight line. That's another way to see that triangular inequality. Okay, an extended triangular inequality, that one, how do you work that? Well, actually, it's you write. Okay, it's not very complicated. It's you begin by saying that x is actually x plus y minus y, and so that it's going to be smaller than x plus y plus y from the previous inequality, right? So that you can you get the left hand side of that one, okay, and the right hand side was the previous one we proved. Great.